When we multiply a vector by a scalar, the scalar gets distributed to all components of the vector. I'll do a simple example here of 2 times 3 comma 4. Now, similar to distribution, we're going to send that 2 to both the 3 and 4, and we'll make it 2 times 3 comma 2 times 4. Simplifies to 6 comma 8. Now that is component form. We can also carry out this same process with vector form, and here it's a little clearer why distribution needs to be used. I and j are unlike terms. They need to be kept separate. So we'll send that 2 to both terms. We'll get 2 times 3i plus 2 times 4j, which gives us 6i plus 8j. Let's say an object is moving northeast at a speed of 5 meters per second, and its velocity vector is vector v. What speed and direction would an object have that has a velocity of negative v? I'm going to draw a little picture of this. Our directions are north, south, west, and east. Now we can make a coordinate system out of this. And northeast at 5 meters per second would be this vector here. We'll call that vector v. So a vector of negative v is going to have the opposite direction, but an equal magnitude. So this vector, the green vector, will be negative v. So let's say the object with the velocity v is moving at 5 meters per second. Then the object with a velocity of negative v would also have a speed of 5 meters per second because the speed is the magnitude of the velocity vector. So negative v points southwest and the speed is also 5 meters per second. Draw yourself an example of a vector u, and then draw negative u. Now go ahead and come up with some numbers for your vector u. And then we'll try to use multiplication by a negative to see what the new components will be of the vector negative u. I'm going to pick the components 3, comma 2. Let's draw that vector. Go over 3, up 2. This is vector u. Now what does negative u look like? Well, negative u would require multiplying a negative times the original components of u. Just like we did above, the negative will get distributed. So negative u will be negative 3, negative 2. Let's draw that vector now. You go to the left 3, down 2, takes you to here. And there's our vector, negative u. Notice that it has an equal magnitude, but an opposite direction by 180 degrees. This next one says, draw an example of any vector w and then show what 2w would look like. Go ahead and come up with some components for w. Could be anything of your choice. And then use scalar multiplication to multiply each of the components by 2 and draw the new vector. I'll pick the components 2, 3. So we'll go over 2, up 3. This will be the vector w. Now let's find 2w. We need to multiply the components of w times 2. Just like we had done above, we want to distribute the 2. We'll get 4, 6. Let's draw that. It's going to have the same direction as w, but it will be twice as long, so it's been scaled up. It's been magnified by a factor of 2.